Hi guys, welcome to my video. So for today's discussion, I am going to discuss to you probability distributions. Probability distribution actually is um, it is a list of probabilities associated with each of its possible values, or it is also sometimes called the probability function or the probability mass function, or it explains or it describes the relationship of the probability of a single element with the probability of other elements at the same or in the same sample space. Okay, so in probability distribution, now we will be dealing with random variables. Okay, so what is a random variable? Okay, a random variable, guys, it is usually written as x, is a variable whose possible values are numerical outcomes of a random phenomenon. For example, I have here example number one. A coin is tossed three times. Let x be the number variable representing the number of tails achieved from this experiment. So what are the possible values of x? So if we draw a tree diagram, we can actually identify the number of combinations, okay, and the combination and the possible outcomes. Now, if we tossed a coin three times, so if h, it could at the first trial we could have a head or a tail. Then a second trial it could be a head or a tail, and a third trial it could be a head or a tail. Now in the other combination it could be a head or a tail, then we have a head or a tail, then the other one we have head or a tail. So we can actually write the combination. We also have int, correct, and we also have h t. Okay, so we also have here h and t. So we also have h t h. We also have t h h. We also have t h t. We also have t t h, and lastly we have t t t. So in total we have possible combination. Eight possible combination. Okay. Now since the question or the problem asked to identify random variable that represent the number of tails achieved, represents the number of tails achieved. So in flipping a coin three times, we could actually have a combination that consists of that contain no tail at all, right? So meron tayong combination na pwedeng walang lalabas na tail, and that is we have the HHH, correct? Or head, lahat ang lalabas. So therefore, we have a random variable which is correct? And we also have a random variable that consists that contains only one tail. So what are those combination? We have HHT, no, isa lang yung tail niya. We have HTH, we only have one tail for this. We have THH, we have only one tail. So we have combination that only have one tail. So we have random variable which is one, and we also have combination that contains two tail. We have HTT, we have THT, and we also have TTH. So therefore, we have random variable of 2. In the other one, we have a random variable that consists all tails. No, lahat ng lalabas sa experiment are all tails. So we have TTT. So therefore, we have a random variable of 3. So this is our random variables, no? Random variables representing the number of tails achieved from this experiment. Okay, now we have example number 2. If we tossed a coin 5 times, so let x be the random variable representing the number of tails achieved from this experiment. So we are pretty sure na may limang combination o may combination ng limang experiment na walang lalabas na tail. So therefore we have x first is we have 0, And also, we are pretty sure na isa lang yung lalabas na tail. And we are also sure na merong dalawang lalabas na tail, or kaya tatlong tail, or apat na tail, or possible lahat ng lalabas na sa experiment are all tail. So this could be the possible random variable for this. And we also have three electronic parts are randomly selected, and each of it can be categorized as defective or not defective. If X is a random variable representing the number of defective parts, what are the possible values of X? So this problem is similar to example number 1. Okay, so if we took three electronic parts, so what would be the possible combination? How many possible combination there would be? So there would be 8 combinations, correct? The same as with example number 1. So we are pretty sure, guys, that um, in our outcomes, no, there would be no defect, correct? Lahat are non-defective. So it could be 0, and there would be outcomes na isa lang yung magiging defect natin, or possible there would be 2 defects, or pwede din lahat ng electronics part are defective. So this is our random variable. Okay? Now, in random variable can be classified into two. We have discrete random variable and we have continuous random variable. When we say a discrete random variable, okay, it is one which may take on only a countable number of distinct value. So therefore, all the value is finite or countable number. So, maka-count natin siya. Okay, there is a restriction. Like for example, the number of female student in IE 101 class 2. So therefore, we are sure na maka-count natin yung lahat ng student. We are restricted only in one class. So they are countable. Now, in number 2, this is also a discrete random variable. Since the number of people in favor of federalism, so it is countable, no? Kung ilang yung mga taong bumoto ng federalismo. So they are countable. And we have also the continuous random variable. When we say continuous random variable, uncountable, no? Ibig sabihin, there are too many possible outcomes, no? Too many possible outcomes are represented by an interval or a number line. So if you remember your number line, so that is in a Cartesian coordinate system. So here it is positive infinity to negative infinity. So there is an infinite number of outcomes. Like for example, no, and also a continuous probability, or sorry, in continuous random variable, some of the example are usually in measurement, no? Example include height, the weight, the amount of sugar in an orange, the time required to run a mile. So they are more on measurements. Like for example, we have number 1, the volume of water in a 5-liter jar. So this is continuous since it is in form of measurement. Okay, the number 2, the number of hours that a person stuck in traffic. So it's also continuous. It involves time here, not the number of hours. So therefore, this is a continuous random variable. Okay, so I prepared a question. No, we identify, or classify the following as discrete or continuous random variable. Okay, we have number 1, number of student present. So we are sure that this is a discrete. Weight of the student in class, since it is measurement, therefore this is continuous. And we also have the number of red marbles in a jar. This is a discrete, no? Countable lang siya. Time it takes to get to school, since it involves time, therefore it is continuous. Number of heads when flipping 3 coins, since limited lang siya, no, that is discrete. We also have students' grade level. No, we have only from primary to secondary, so therefore countable, that is discrete. Height of student in class, since it is a measurement, therefore it is continuous. And distance traveled between classes, so again this is continuous since it talks about the measurement or distance. Okay, so that is how you classify discrete or continuous